10.8 deals with systems of non-equations. So those are two parabolas, a parabola and a circle, a parabola and a hyperbola. We're going to graph all of those later on in chapter 11. For now, we're going to do the algebra of this. So a couple of ways you could do those. One way you could use substitution, such as you could say y equal 2 minus x squared. Take this value and embed that right there. And that would become 3x squared plus 2. Instead of y, it's 2 minus x squared equal 15. Then you'll get 3x squared plus 4 minus 2x squared equal 15. X squared equals 11. So x equal plus or minus radical 11. So now I know the x coordinate is plus or minus radical 11. If I substitute that in there, that would mean y equal 2 minus x squared was 11. So y equal a negative 9. And those would be the solutions. Notice I could have, if I wanted, multiplied this by a negative 3 and added those. That will work as well. You could do either or, whatever you like. You should practice both. Here's another problem. If I look at that problem, say, okay, well, I could use substitution just like I did, or I could say, you know what, multiply this by a negative 3. The top equation is 3x squared plus 4y equal 12. The bottom equation is negative 3x squared plus 3y squared equals negative 5. If I add those, right? So that is 3y squared plus 4y equal a 7. 3y squared plus 4y minus 7 equal a 0. So 3y and a y, a plus 7 and a minus 1. That should do it. 3y squared plus 3 minus 3 plus 7 is 4. There you go. So y is negative 7/3 or 1. If y equals a 1, plug y equal 1, you get 3x squared plus 4 equal 12. 3x squared equal 8. Divide by 3. X will equal plus or minus square root of 8 over 3. You could rationalize if you want. And if y equal negative 7 over 3, then 3x squared minus 28 over 3 equal a 12. Clear the fractions. 9x squared minus 28 equal 36. 9x squared equal, if you add those, 1468 divided by 9. So x would be plus or minus 8/3. That's would be my solutions. Again, we're not going to graph those because we have not graphed the hyperbolas first. I was tempted to do those at the end, but this was recommended. Probably I'll switch that next time I teach the class. So how does this work? Again, it's up to you. If I solve for y equal x over 4, take this and substitute that right there. That would mean 2x squared plus x over 4 squared equal 12. 2x squared plus x squared over 16 equal a 12. So 16, 32x squared plus x squared. What's 16 times 12? 18. $198. So 33x squared equal 198 divided by 33. X squared equal, if I divide, that will be a 6. So x equal plus or minus radical 6. And hopefully I didn't make an algebraic mistake. If I did, you get the trend. If x equal radical 6, put radical 6 in there. Y will be radical 6 over 4. And if x equal negative radical 6, y would be negative radical 6 over 4. The reason I wouldn't put plus or minus radical 6 and plus or minus radical 6 over 4. This is 4 solutions. So make sure you do each individually. I want to solve the following equation. Well, I notice I could multiply this by a negative 3 and add it to that. Or since that's negative and that's positive, I could multiply this by a 2. That will make this 2 over x squared minus 2 over y cubed equals 0. And the top is 3 over x squared plus 2 over y cubed equals 5/4. And if I add those cancel out. I'll get 5 over x squared equals 5 over 4. Cross multiply and divide. I'll get 5x squared equals 20, or x squared equals 4, x equals plus or minus 2. If x equals 2, I'll go to either equation. Let's go to the second equation because it has a 0. I'll get 1 over 4 minus 1 over y cubed equals 0. I'll get 1 over 4 equal 1 over y cubed. Y cubed equal 4, so y equal the cube root of 4. And if I chose the negative 2, I'll get, well, it's the same thing, right? Because you're going to square it. I'll also get the cube root of 4. Those are the 2 solutions to this system of equations. 2 more to go. If I glance at this, I notice this is very challenging. Well, what can I do? I could solve for 3 to the x or 3 to the y. Let's say 3 to the y equal 12 minus 3 to the x. I could take the bottom equation and say that's 9 to the x minus 9 is 3 squared to the y equals 72. 9 to the x minus, and if I swap those, because that's 3 to the y squared equals 72. So 9 to the x minus 3 to the y is 12 minus 3 to the x squared. So 9 to the x minus 12 plus, minus, if I FOIL 144, minus 6 times 3 to the x plus 3 to the 2x, which is 9 to the x, equals 72. So that is 9 to the x minus 144 plus 6, that's not 6, 2 times 24. 24 times 3 to the x minus 9 to the x equals 72. Those cancel out. I have 24 times 3 to the x equals 72 plus 144. That is 6, 11, 216. 3 to the x equals, so I'm isolating the trig function by itself. 216 divided by 24, that's a 9. So 3 to the x equals 3 squared. That means x equal a 2. And if x equal a 2, y would be 12 minus 3 squared, 12 minus 9, which is a 3. That would be the solution to those 2 equations. Alright, last problem. Well, I'm going to use elimination as well. I'm going to multiply the top equation by a negative 1. That becomes negative log of x minus log of y equals negative 3/4. And if I add those cancel out. That will be 3 the log of x divided by 3. So I'm isolating the log by itself. And x would be, the base of this log is a 10. That would be 10 to the negative 1/4. Or x would be 1 over 10, 10th root, 4th root of 10. Oh boy, I got them backwards. The 4th root of 10. And now if I go to either equation, let's say the bottom equation because it has a 0, 4 times the log of x, but the log of x, I could go this far. The log of x was really negative 1/4, plus the log of y, equals 0. Negative 1 plus log of y equals 0. Oh boy. So log of y equal a 1, and y would be 10 to the 1. So the solution here is 1 over the 4th root of 10 and 10. And that would be it for this section.